next week. What time? Which day, I mean? Is it you want Monday or you want Wednesday? Wednesday? Yeah, I prefer Monday, you know, because you'll be fresh from the weekend, you know. You study in the weekend and you come fresh in the Monday finish, you know. Wednesday? Okay. Okay, so you prefer Wednesday, right? So we take it on Wednesday, no problem. Inshallah, I will send a mail to confirm the time. So let's look at chapter 3 of cloud computing course. As usual, we are using the Huawei's HCIA cloud computing materials, the slides. So this chapter will also be based on the slides provided by the Cloud Security HCIA certification for Huawei. And the chapter is on storage technology basics. We already discussed a little about the basics of storage devices in chapter 2, but in this chapter we will introduce more details into it, and we will see how storage devices evolves from normal traditional storage devices in the computer that we have to storage devices in the cloud system, to the network system, and then to the cloud system. So in this chapter, we will detail all this information, inshallah. Forward. The forward is about data. Data and information are the most important and the most confidential piece of objects that we try to manage in the network, in the cloud, and also on our devices. Therefore, we store this piece of data called information into what is called storage device, right? So after we store it into the storage device, sometimes we need it, we can simply go back to it and retrieve it, right? But then, because of the number of users coming online these days, individually we have maybe 2 phones, 1 laptop, 1 desktop at home, and so many other devices. All these devices are generating more data. Then suddenly you realize that the storage device on your piece of device that you are using may not necessarily be enough. Okay? But then we have cloud services that provide additional space where you can store data. That includes videos, files, audios, images, and lots of data that you generate every day. You snap pictures and stuff like this, you know. Therefore, the cloud service is a saving grace that helps us to manage data more accurately and in a way that it can be scalable. Okay, when we need additional space, we can increase it. Okay, and of course, we can be able to manage this data more carefully with cloud computing technology. So basically, this is the forward. The forward is about cloud computing and how it's used to manage data. Okay, so data, because of it's important and it's growing every day. Okay, it's increasing every day. We need additional storage technology, and basically the cloud computing technology help us to store more data that we need. So let's look at the objectives of this chapter. The objectives of this chapter are to understand the mainstream data storage modes and network topologies. There are different types of data storage modes. This objective, we will try to understand the differences and how they work, especially in a network topology. We will also try to master RAID devices, okay? And Huawei RAID 2.0 plus block visualization technology. So inshallah, I think this will be in the next class. But in this class, yes, we will do this. In the next class, we will take this, okay? Distinguish between centralized and distributed storage. Yes, we will do this in this class also. Understand storage protocols and application scenarios. Yes, we will do part of this, and we will complete the remaining ones in the next class. So even though they arrange the objectives this way, but the slide is arranged in a different way. This is one in the slides arrangement, this is two, and this is three, and this is four. So storage basics. We will start by defining what is storage, okay? History of storage, mainstream disk types, storage networking, types of storage forms, and in section 2, we will discuss about the key storage technologies. I will also add to the fact that the slide itself, as designed by Huawei, in some instances is not very informative, okay? So I try to add additional information to give the students better understanding of what is being discussed in that section, okay? So what is storage? By mere looking at this slide, there is nowhere you can find the definition of storage. Can you find the definition of storage on this? So it's designed in such a way that we have to look at the diagram and just explain what we can see, okay? But then, maybe after this class, the student will go back, want to read the slides again. What is storage? There is no definition. You will be confused where to find the definition of storage, right? So I try to add additional information. I said storage in computing refers to process of saving, retaining, accessing digital data, because it's all about data. Don't worry, after the class, after I complete this chapter, I will also upload my own slides where I make all this additional information available, okay? So that, yeah, for further reading, you can read it, okay? For various type of devices. So basically, we can save, we can retain, we can access digital data and information in various types of devices or systems, okay? This allows data to be preserved for future use, whether for short-term or for long-term purpose. For example, you may store information or save information, and after many years, you can still come back to it, right? So this is for a long-term purpose. But short-term purpose, maybe you save the information today, and you still come back tomorrow and continue to work on it. Maybe it's a lab configuration you started, but you have not completed it. So you can save your files, and then you come back tomorrow, and you go back and continue with your lab configuration, right? So this is for short-term purpose, okay? So this is basically how it works. However, if we go back to what we know, because it's always better you explain to the student based on what they know before, okay, before you add new information. So what we know before, especially in computer fundamentals, is that storage is divided into two types. That's what is called primary storage and secondary storage. Primary storage is like a RAM. RAM is a volatile memory. Okay? But then we have secondary storage. Secondary storage is a non-volatile memory. Okay? So I will try, I add this also. Now, let's look at what happened in your PC. In your PC, the information that the CPU or the processor is trying to execute can temporarily be stored in a RAM. Temporarily. Okay? If you store it in a RAM temporarily, that means that the RAM can always go back to the temporary memory when it needs it and fetch it and execute. This makes processing very fast. It is not always that the RAM have to go to the hard disk, okay, to fetch information. This takes a long process if always the RAM has to go to the hard disk. That's why the RAM, sorry, the processor or CPU keeps some temporary information in the RAM. Okay? These are volatile information. Now the implication is that this type of information, if you shut down your computer and you boot it again, the information is gone. You cannot find it again. That's what happened if, for example, you are typing in Microsoft Word or Excel. The information is there, but you are yet to press save. So where is this information kept? This information is actually kept in a volatile memory like the RAM. Wa alaikum assalam. So this information is kept in the RAM, okay? But then the RAM is a volatile storage device. So if by mistake your computer goes off, if you boot it again, you are not going to find the information because it's stored in a temporary memory or primary storage device. Okay? But then the moment you press save, it moves away from the RAM, it goes to the hard disk. Okay? So it moves from primary storage, it goes to a secondary storage. Okay? But the secondary storage is a non-volatile memory, implying that even if you boot the system again or restart the system again, you will still find it because it is now in a non-volatile memory. You already saved it. Okay? The type of storage devices that are used for this purpose are the hard disk, okay, that's hard drive, HDD, the solid state device, SSD, we discussed them in chapter 2, SSD, okay, and the USB, optimal disk, and of course, cloud storage. All these are non-volatile storage devices. If you boot your system, restart your system, if you go back to find the data, you will find it if it is in the secondary storage. However, if it is in the RAM, if you reboot your system, if you go back, you will not find it because it's a volatile memory. Volatile means what? Something that can quickly disappear. That's what it means. Okay? So now this is to refresh our memory on what we know about storage. Now let's look at this diagram. This diagram shows the users, okay, and the employees. These are the primary people that generate data because the discussion starts with data, right? The users and the employees are the primary people that uses computers, devices to generate data. Maybe we use applications like MS Word and stuff like this, okay? So all these generate data, okay? And the data goes to the server where it's stored, okay? The server, it can be a database server, it can be a mail server where we have our mails, emails, okay? Or it can simply be a file server that uses like protocol like FTP, file transfer protocols. Okay, so basically, data starts from users, Okay, we use applications and generate data. Applications like camera. We use the camera, we snap pictures. The picture is an image, it's generated as data, and it can be saved in a database or any storage device. Okay, so basically we start with what? Data generation. And from data generation, we go to processing. So we process the data and store it in a device. What does the processing is the applications. The applications process the data. Okay? But then these days, these physical servers are not longer enough to store our data because now we are generating heavy data. We are sharing heavy data, especially on social media, go to Instagram, go to TikTok, go to YouTube. We are always generating more data. Therefore, these physical servers are no longer enough. We may need to have what? A cloud storage, which is what? Online. Okay? So now we are talking about data management. Data management. Okay? Data management is moving from physical servers, because these are physical servers, now to online storage. Okay? In the online storage, we have cloud servers, we have data centers. Okay? This is where our data is being stored. Now, the advantage of this, we mentioned in previous class, is that if you lose your device, you only need to get another device, and you log into your account, and your data will come back, right? Backup. Yeah, it's a cloud backup, of course. It's a cloud service. So, but then it only works when there is internet connection. Okay, so it's basically dependent on internet connection. Okay, however, if you are offline, this may not be accessible. Your data may not be accessible. You can't get your data if you're offline. You cannot. You have to get internet connection to get your data when you save it in an online storage like the cloud service. So basically, this is how storage is defined. It starts from data generation to data processing and then data management. And it moves from users and employers generating data using their devices, be it a mobile, a laptop, or a desktop, using different applications like Microsoft Word and stuff like this, and then you save in the cloud. Okay, if you save in the cloud, this is basically an online service. But then if you save on a data center, on a server, a physical server, yes, you can access it even if you don't have internet connection. Just a simple network connection will be sufficient to access your data on a server. However, you will soon come to realize that the servers are not enough to host all the information we are generating right now. Okay? Therefore, we need online service, which is the cloud base, which actually is limitless in terms of the capacity of the information that it can store. Any question on this? So let's go to the history. History of storage. Storage starts with traditional storage. Okay, traditional storage look like this in the 50s, where you have storage in tapes, okay, and you store the tapes in something like this. Then we have external storage in the 80s. External storage, it comes in this way. Okay, you can have the external storage and you can add additional storage to it. Mostly it's a one disk type of device, but then sometimes it can be you can have external disk. That's why it's called external storage. External disk that you can connect to the PC and still store information. Okay, but in the 90s, we have storage networks. This is where networks already start. Okay, in this case, you can have multiple disks, okay, being managed by what is called a controller. A controller basically can have multiple disks, and it will look at it as a logical one disk. Okay, logically it will be one disk, but physically you will have multiple disks. Okay, all of them will be packaged in the same box like this. Okay, and then you will have a switch, and then the servers connected to it. So this controller can help you to add additional information in this disk. Okay, because it's a network, and you have your Ethernet switch, which that's using an IP address. Okay, and then you can have your service. So all these can store information here, and the controller will help to manage all the information that is being stored on the disk. We will explain this more in the coming slides. Okay. But then now in the 2000s, it's all about cloud service. Who can remember when the cloud started? Which year? You remember? According to the previous slide, 2012. Yes, you're right. 2012. That was when this cloud computing started. Okay. So we now move from the 90s. Okay. From 2000, early 2000, specifically 2012, we start to have the cloud storage, which is more or less a distributed storage type. So this is the history, basically. I don't like history. I prefer to go to the IT aspect, not to discuss history. History is for people in history. Let's go to another section. Because I'm recording, I don't want to be too far away from the PC. If I go too far away, the voice will not appear in the records. Okay, so let's look at this. Let's take them one after the other and take time to explain. Okay, this is a normal server. At this point, we already understand that a server is the same as your PC, except that it has more capacity, right? Now, in a normal server, just like in your normal computer, you have a single hard disk. Okay, so you have your disk because we are talking about storage. Then we have the RAM, which is a temporary memory or primary memory or volatile memory. And then we have the CPU. The CPU is the processing machine or the processor. Okay, the processor contains how many items in it. In the last class, we understand that it has the register, it has the ALU, that's arithmetic logic unit, and it has the controller in it. Okay, so we know what is contained in a CPU. So information coming here or data coming here is being processed, sometimes stored temporarily here, but then the aim is not to keep it in a temporary memory. It's always in a temporary memory only because the CPU will need it, and the CPU see that it will take a long way to go to the disk. Rather, it keeps it somewhere close. Okay, so it takes it from here and executes, takes it from here and executes. When it's complete, the execution or processing is done, then it can send it to the disk. Okay, but when the data is still being processed, the CPU rather put it in a temporary memory, which is easy to access and execute. When it's done and you press save, then it goes to the hard disk. This is how it works. But now, we simply come to realize that this system is not sufficient when you talk about data being generated now. Now we generate a lot more data. So even if you have 1 tera on your PC, you will soon realize that it's not enough. Even in this college, by the time you finish with Dr. Nadir's class and you install some applications. You come to another class, Shafi's class, and you install some applications, simulators. Go to Dr. Abdullah's, Dr. Tahani, and you keep installing lots of simulation packages. Then suddenly your system will start telling you that you don't have more space. Okay? So that means that this system, if it is getting filled up, it will affect the performance. So now let's talk about the disadvantages, which is the restrictions. It will affect the performance. Okay, system performance will be affected. Okay, that's one. The number of disk slots is limited because now we have only one disk. Even if you decide to add another disk on your laptop, the space is not much there. Maybe you can succeed to add one additional disk to make it two, but two is still not enough. Okay, so we have limited number of slots to add additional capacity. Okay, it limits the capacity. Data stored in a single disk, lowering data reliability because everything is stored here only. Now the question is, what if the disk get crashed? If this disk crashed, what happened to your data?
All the information will be done.
It's done, right?
Yeah.
Is it reliable? It's not reliable. So that means that there's problem with reliability. Storage space utilization is also low. Because you are using only one disk, utilizing the spaces is low. Okay? This you can only see it when you look at the hex values of the disk. Okay? There are softwares that we use in forensic class to show all this. Okay? So storage utilization is, in terms of the space, is very low because you have limited space. So how you can manage this space? If, for example, you duplicate a file, a video 2 times, it occupies twice its space on the disk, right? This is not a good thing.
Yeah.
The disk is supposed to only take one of the file. So if you duplicate it, it takes two, right? So the space is not fully utilized. But there are other systems, like a distributed system, whereby if you duplicate the file, it is not going to be stored on that disk. It will rather store it on another disk, so that redundancy will happen. If the disk gets crashed, you can still retrieve it on another disk. This is when you have distributed type of distance. So we will talk about this in the next one, okay? Data scattered on local storage. So these are all the restrictions. So let's see the next one. This is the first one when you have a single server. This is the second one when you have external disk arrays. The same server with a CPU, a RAM, and a disk. But we just mentioned that this disk is not enough on the server. So we try to figure out a way to increase the number of disks so that we can increase the number of storage and the performance of the server. What do we do? So we need what is called just bunch of disk, which is also called JBOD. JBOD is externally connected. You can simply connect it to your PC and you can add the number of disks in it. Okay? So you can add the number of disks. It's just like a box. Okay? Inside the box, you have these connections where you can add more disks. Okay? This is done using a disk card called SCSI card. SCSI card is also called Small Computer System Interface card. That's the full meaning. Okay? So it's simply just a card that helps you to connect your disk with the JBoard and the data being transmitted through it. Okay? Sorry. So basically you have HCIA card here. It's simply a card that is connecting your disk to the JBoard, and in the JBoard you can add so many hard disks. So if you have so many hard disks in this, it will help you to increase the storage space and increase the performance. Okay? So basically, JBoard logically connects several physical disks to increase the capacity. Okay, so you can add many physical disks here just simply because you want to increase the capacity. Okay, this is the essence. But it still has some problems. It hasn't solved all our issues yet. So for example, the number of disk slots is limited. Now the thing is, JBoard maybe has like 10 slots and you keep adding disk. You keep adding disk. If you are dealing with an organization that deals with heavy graphics like maps, people that work in uh, geographic information systems, they deal with the map of the country. Now, the interesting thing is the map of Qatar, for example, is changing by the hour. Because maybe this morning they are constructing the road here, tomorrow they block the road and change it to another place. Now, this is the thing. The map, the GPS map needs to be updating every time, right? Otherwise, people on ways trying to find their location, they may always go into the wrong way if the map is not updated on real time. Okay? So now imagine the map of Qatar being updated by the minute. How much time will it take before all these hard disks will get filled up? Easily, it can get filled up, right? So if you are dealing with heavy graphics, it will simply fill up even the JBoard that you are using. So that means that the number of slots in the JBoard is still limited. It's still limited. Number of disks, even though we somehow find a way to increase and better than the first scenario, now the second scenario, we still realize that it still has some issues. Then we move to the next scenario, number 3. Number 3, we still have our CPU in the server, we have our RAM, and we still have a disk. But then we are trying to be a little bit more intelligent than before by introducing the controller. I mentioned a little about the controller, discuss the history, okay? But now I will explain more about the controller. The controller, aside from the HCIA, SCSI part, the controller also has
touch reading not supported.
To control disk, okay? It helps to control disk. So with the controller, you can create what is called, you can create what we call RAID devices, RAID disk, okay? So controller can give us the RAID function. If you remember, there are different types of RAID. We have RAID 0, RAID 1, RAID 2, RAID 3, RAID 6, I think. And then we can have combination of 0 and 1, it will give you RAID 10. If you have 2 RAIDs, RAID 1s, it will give you RAID 11. RAID 1 and RAID 2 will give you RAID 12, like this combination of different RAIDs. So these functions only applicable when we introduce the controller. The controller helps us to manage bodies and create RAID functions. And in RAID functions, we can have more redundancy, We can have stripping, we can have mirroring of devices, okay? These are additional functions that the controller can give us. In addition, it is more easy to control the disk that we are adding if we have a controller than when we are using just simply a JBoard. JBoard is limited in managing the disk. But still, we solve one problem, we create more problems. So even this scenario, intelligent disk array, still have some issues because this becomes the system performance bottleneck. As we add more disk, it may affect the performance of the system. The number of disk slots is limited. No matter how we try to increase the number of disks, we would still reach a limit to it. So limitation in this, okay? Then data stored on a single disk, lowering data reliability, and yeah, so also if we store the data on a single disk, maybe it will affect the reliability of the disk, okay? So these are some of the problems that are still applicable in the third one. Any question? Actually, the cloud computing starts after this, okay? After this, cloud now comes in to solve this problem. Because all this happening in a physical device. But then you want to do now storage in what? In a cloud device. So storage becomes even more in terms of performance, speed, and all the problems that we mentioned here. Most of them will be gone when we start to apply the cloud. Yes. But before we discuss that, let's discuss SAN and NAS. SAN and NAS are storage types that are used. The SAN is called Storage Area Network. The NAS is called Network Attached Storage. We need to understand this concept before we understand how storage is done in a network environment. Okay? Now, let's look at this class and this lab. You have a PC in your front, a workstation. If you create information and you store it, where do you think it's being stored? Sorry? Oh, sorry, I forgot to mention. I created it and added it. Okay? This slide is not in the original slide. That's why I said at the end of chapter 3, I will update and give you my own version. Because all this information I added are mostly not in the original slide.
Because you're writing all the notes and the slides.
Yeah, writing notes?
Yeah.
Yeah, it's okay. I'm also writing notes. Anyway, so I will update it maybe after the class. But again, I haven't finished updating. Today I will only take half of chapter 3. Next class I will take another half, okay? And then that's when all my modifications will be complete. Because I realize that the slide is not comprehensive enough. So to make it comprehensive, I need to add additional information so that the student can understand it better. So basically, these are two types of storage that is being in a network environment. Okay, this is a network environment. We have PCs, right? They are all generating data. Where is it stored? It's stored in the server, and the server is not located in this room. Okay, if, for example, if you go back to your house, you have a normal PC, for example, you will have the PC and you will have the system unit, right? In the system unit, you have the hard disk, right? So basically what it means that if you generate information, it's stored in the hard disk. Now, where is the hard disk of this one? Yes, there is a small memory that helps to manage temporarily some information in here, but it's not enough. So basically, what they do here, they connect this all these ones to a server. So if you save, it goes to the server. That's why sometimes there are some places you cannot even access. You cannot access the memory or the hard disk of this device because you don't have administrative privilege to access the server. Okay, so you cannot access. So basically, if we have to do that, we will need to apply either SAN or NAS or both. Okay, this is storage in a network environment. So this way we need SAN and NAS. In terms of data access, SAN uses what is called block level, while NAS uses file level. Actually, to make it easy for you, NAS always has to do with files. SAN can have other type of data, videos and stuff like this, but it's stored in blocks. We will explain this more, okay? In terms of connection protocol, the SAN uses fiber channels. It uses the HCIA that we mentioned and FCOE. This is another protocol. While the NAS, it uses the network file system because it deals with files. Okay, either it uses NFS or it uses CIFS. CIFS also is Common Internet File System, also with files. Or it uses the common one that we use for files, which is FTP protocol. FTP means what? File transfer protocol, right? That's why I didn't write it, because I know it's common. You have learned it in computing fundamentals, fundamentals of networks, fundamentals of network security, firewalls and VPNs. All they mention for you FTP, protocol that manages files in the network. So NAS also uses that. But mostly it uses the first one and the second one. NFS, Network File System, CIFS, Common Internet File System. So in terms of performance, the SAN has more performance, okay, than the NAS, because the NAS only works with files, but the SAN uses other types of. Likewise, in terms of scalability, use case, in terms of use case, you can use SAN for database visualization and other stuff. But NAS is for file sharing. Anything that has to do with file is NAS, okay? Expensive, cost, in terms of cost, the SAN is more expensive than the NAS, basically. So these are the things that we need to remember. Now, if I have to ask you a question, why do we need a NAS? What will you tell me? For file sharing, excellent. Just remember files. How about the SAN? Other types of, yeah, it's used for block storage of other types of data, basically. Okay, like video and stuff like this, okay. But NAS is for file sharing, just remember this. So let's look at this. Now we are back to our normal slides. That slide, I added it because I want you to know the SAN and the NAS, because in this Huawei slide, they just started talking about NAS and SAN without telling us what it means, okay? So I feel like maybe the student will be confused to understand what it means. So that's why I added the table, okay? Before we look at the slides. So now we understand this already. We explain it in the last two slides. This one, this is it. We understand it. Okay, we added a controller to manage disk that we add here. Okay, simply because we want additional functions to the disk and be able to create RAID devices. Okay, and manage it and manage different RAID devices. So that's why we explain this now. But then after we finish explaining all this in the previous slide, we still mention problems that it has. It's limited in terms of adding the disk, okay, and it sometimes affect the performance, okay. We mention all these problems. Now, to solve these problems, we try to create a network type storage. So you can see the arrow shows we are now moving from what happened in a single device to what happened in a network environment. Okay? So now we are moving to network environment, how basically data is being stored in a network environment. To achieve data storage in a network environment, we need the SAN and the NAS. The NAS will help us to manage files, okay, file system within the server. While the SAN will help us to manage other type of data using a RAID device. Okay? Now, look at this. The SAN also have file systems, but it's managed within the server, not within the storage device. SAN have a connection type called the SAN, while the NAS have a connection type called the LAN. This helps us to manage and create more spaces for the hard disk, because you can see that you can have more than one server using the same storage device. Like what we have in this lab, we have many PCs, but they are actually using only one server's storage device. Okay? So, but this did not still solve most of the problems mentioned. So this becomes system performance bottleneck. Okay, this issue is still there. The limited slots, issue of reliability also is still there. Utilization is still there, and data cannot be shared. Now this is another issue. So when we try to solve one problem, we create more. Mainstream disk types. That's why we need cloud, you know. Cloud is so superb. Do you have any question on this slide? No question? So let's go to the mainstream disk types, where we'll discuss storage network and storage forms, basically. You remember this slide in chapter 2? We use this slide exactly as it is in chapter 2. This slide explains different type of disk. We have the SATA disk, the SAS disk, that's SAS disk, NLS SAS disk, and SSD disk, basically. The SATA disk, we said, is actually the SSD is more expensive, but the SATA disk provide more storage space, basically. In terms of capacity, you can have 1 tera, you can have 2 tera, 3 tera of SATA disk. Actually, now you can have even tera of that SATA disk, P. But you can see the SSD have like 0.6, 1.2, 1.6, yeah. But in terms of speed of processing, basically, and storage, read and write, the SSD is actually very good for that. Then we have the SAS and the NL SAS. These are also another enterprise type of disk that are also very good in terms of performance, okay? And they are compatible with the SATA disk. They are compatible with SATA disk. The annual failure rate of S is less than 2%. That means that it's very reliable. It doesn't really fail much. It doesn't fail much. Likewise, the NL SAS, because it's an advanced level of this of the size. Also, the percentage of failure per annum is just like 2%. So that means it's very reliable in terms of strength. Actually, we discussed this slide already in chapter 2. So they just simply try to recall and remind us about the type of disk that we mentioned. So if you want to select a disk, what are the things you want to look at? You want to look at the disk capacity, how much space, okay? Rotational speed, this is only for the HDD. HDD is the hard disk. Average access time, data transfer rate, input output operations per second. These are the things that we want to look at when we want to select, anytime we want to select the type of disk that we need. So based on these parameters, we can have the disks that we mentioned: SATA, SAS disk 10K, SAS disk 15K, SATA SSD, SAS, SAS SSD. We have also NVMe SSD disk. So you can see that as the time progresses, you will see that the input-output operations per second keep increasing, okay, from the SATA until the last SSD card, which moves from 330, okay. Now we can have up to 300,000 input-output operations per second. But in terms of the bandwidth, also you realize that from the SATA, it keeps increasing from 200 megabytes per second. Now we can have up to 3,500 megabytes per second of bandwidth in terms of the read and write. That's if you consider 124.38 kilobytes of the bandwidth, basically. So this is how the SATA disk is, the different types of disks are increasing in capacity, okay? That's this, in rotational speed, average time, data input transfer, and the IOPS, which is input output operations per second. This shows that basically there is increase in the technology in terms of the input output per seconds, and that means that we now have better performance hard disk in the market. Also, in terms of bandwidth, you will see that the bandwidth also is increasing. Storage networking. What? I'm targeting to stop at slide number like 25 because we have like 50 slides. I couldn't believe I'm still in 14. What have I been discussing? It's more than 1 hour already. What if we wanted to like finish the slides at once? It would be a very long class.
And too much information.
The information will be too much, but now the information is not too much, right? So far it's okay, right? Please, if it is too much, tell me so that I can stop. Yeah, we took it before, yeah. So let's look at storage networking. Actually, let me see. Let me take you back. Okay. Storage networking. Where is my marker? This is divided into 3 actually. That's what is called DAS. Okay. We have the sun. We discussed the sun, right? And we have the what? The NAS. So now We will take the first one and discuss. Second one like this until we finish. Okay. Now we already have an idea of what SAN is and what NAS is, but we don't have an idea of the first one, DARS. So introducing DARS. In trying to introduce DARS, we have still a controller. A controller, we understand, can help us to manage disk and make configuration related to RAID devices, okay? We have a server here, okay? The server uses what? A hard disk. Hard disks are multiple hard disks connected, okay, through what? A SAN connection. Through a SAN connection. SAS connection, sorry. SAS connection. Through a SAS connection. Or we can have the connection through fiber channels, which is called FC. So moving forward, if you see the word FC, it means fiber channel. But then sometimes the connection is done using HCSI, which is what? We mentioned it before. Small computer system interface, right? So DARS uses 3 protocols. Okay? It can use the protocol called SAS to connect between server and disk, or it can use the protocol called FC, fiber channels, or it can use the protocol called CSSI. Okay? These are the 3 protocols that I use. You can have bunch of this connected through this with a controller, but these are the protocols that basically helps the DAS to function. It was first created in 1970. The full meaning of DAS is direct attached storage, because it's directly attached to the server. But it's done through what? A SAS or through FC or through SCSI. These are the protocols that helps the connection. So connection mode, you can see the connection mode is through fiber channels, SCSI, or through SAS. Okay? Access mode, most of the servers, the access mode is between the DAS and the server host. So you can have the server host, and this is basically the DAS arrays of disks that are in there. In terms of link rate, how much time it takes for data to go from the server to the disk, it can go like 3 KB per second, okay, 6 KB per second, 12 KB per second. Actually, this is huge data, you know, very huge data. If you have to save 1 gig, can you do it in a second? It takes more than 1 second actually, 1 gig. Even if you have very good speed, it takes maybe sometimes, you know. But now this can do actually up to 3 gig in a second. So this is like very high speed actually. Okay, but in addition, it has the advantage of taking snapshots of the disk to keep as backup. So if like a disk gets crashed, you can get a snapshot and you can recover the information. So this is the advantage of using DARS basically. Any question related to DARS? What you need to remember is it uses 3 connection protocols. Okay, the first one is SAS, FC, that's fiber channels, and SCSI, which is small computer system interface. These are the connection types. Even if we ask questions, it will be around this, you know. So let's look at NAS. Now, the good thing is, at this point, you already know what a NAS is. The table I created and added to the slide explained to us between the difference between SAN and NAS. Okay? And it tells us from there that NAS is for what? File sharing. So easy. It was first created in 90s. Okay? It uses different types of operating systems from Unix, Linux, and Windows. It all uses. Okay? But the connection type, okay, it uses a dedicated storage RAID device, that uses IP, okay, to connect with this. But the protocol used is NFS, you remember, Network File System, or you can use CIFS. Is there in the table already? Okay, it's just shown now in the diagram. Okay, the table I created already showing. So it's either you use this or you use this, but you need an IP to do that. Okay, so it uses IP connection with these protocols. The advantage is the system, the file system is on the back-end storage device. So basically, the file system is stored on back-end storage device, and it can provide some kind of backups also. It can handle large data sharing and exchange, of course, related to files only. Yeah, because the NAS deals with the files. In addition, okay, this is like more detailed diagram. The disk are actually logical disk, and they number it, okay, according to units. So we have what is called logical unit numbers, like this is lon 0, lon 1, lon 2, lon 3, basically. So the meaning of LUN is logical unit number. I guess it's not there also in the slides. You can put it. So the NAS handles file systems, okay, in different volumes, and Ethernet port connection because it uses IP, dedicated IP, as we said here, okay, it uses a dedicated IP. So you need an Ethernet switch actually. How about SAN? SAN uses two types of connection. The IP connection, the IP uses the Ethernet switch, okay, or the FC, the fiber channel. The fiber channel uses fiber channel switch, FC switch. Now, in diagram, look at the difference. The IP switch or the Ethernet switch, you can see it in blue. Okay, the FC switch is shown in orange. Okay, they are not the same type of switches. So the servers connect with an IP or Ethernet switch in order to send or to receive data from the storage device. This is what happened in a SAN. Okay? It can either use the IP, which is the Ethernet switch, or it can use the FC, fiber channel. So if we are talking about the FC for the fiber channel, this is how it looks like. You can see it's using FC switch, the orange one, not the blue one. The blue one is IP or Ethernet switch. Okay, it's using. So this here tells you that we are using FC SAN. Okay, FC SAN. So the FC SAN have FC SAN controller, which helps to manage the disk. And the disks also are numbered according to logical unit numbering. So we can have LUN0, LUN1, LUN2. That's how the disks are managed. Okay, so it can actually save on different LUN logical disk, and it can be able to retrieve it. In terms of speed, you can send and receive up to 1 gigabyte per second, or 4 gigabyte per second, or 8 gigabytes per second. The main advantage is it provides advanced data protection functions such as snapshot and disaster recovery. Yeah, in terms of disaster recovery, because it's using LUN disk, you can recover information from other disks, basically. Yeah, SAN LUN are created to represent specific storage blocks that servers treat as physical drives. So you have all these logical blocks, which is the LUNs. So these are the LUNs drives, okay? All this together, it will be reading it as a single unit or a single physical device, basically. But once an IP SAN is used, the story is different. In an IP SAN, Ethernet switch is used. Okay, so we use Ethernet switch. You can see the switch now is the blue type. So this is for IP link. Okay, it connects the server to the storage where you have the LUN devices. Okay, these devices arranged in arrays. Basically, yeah. So this one, the speed is not much. You can have up to 1 gigabyte per second, up to a maximum of like 10 gigabytes per second. Sending and receiving information, basically. This technology is used from 2001 actually. The comparison between DRS, NAS, and SAN. Let's look at this. The SAN have two types of connection: FC SAN and IP SAN, right? So this one is for fiber channel, this one is for IP address that uses Ethernet switch. In terms of data type, SANs simply works with block level. But NAS is file level. The DARS also is block level. But I forgot to mention, actually we mentioned already, okay? The DARS has 3 different types of connection protocols, which is HCIA, fiber channels, and SAS. That's the first thing we mentioned when we mentioned that. Okay? An application scenario, DAS can be applied in any scenario. However, NAS can be applied only on file servers because NAS is for files, file sharing. Then we have SAN. SAN is database applications, video security, and the advantage of using the DARS is that it's easy to understand and it's robust in compatibility. The advantage of using a NAS is that NAS is easy to install and is low in cost. Okay, the advantage of using the fiber channel SAN is that it brings high speed, okay, high performance, high availability, and high scalability. And also is IP SAN gives strong scalability but low cost. These are the advantages. In terms of disadvantages, the DARS is difficult to manage and is limited in scalability, low storage space utilization, while the NAS have low performance, incapable to inapplicable to some applications because it only works with files. So if you have like videos and stuff like this, it may be difficult to manage. Okay, so files are only applicable, so it's limited and incompatible with some applications. The FSAN, the FSAN is expensive and complex in configuration, poor networking compatibility, while the IP-SAN has low performance. That's the only disadvantage. So this summarizes all what we have said in the previous slide. So let me just go back a little. The slide starts from here. DAS, NAS, and SAN. Now, we can add more information from here. We can say that DAS has what? 3 types of connection. What are the connection types? Who can tell me? S, A, S, exactly. Fiber optics or fiber channels actually. FC, okay, and it also uses what? SCSI. That's for that. How about for SAN? For SAN, it uses 2 types also. SC and IP SAN. Right? How about NAS? NAS. It uses NFS and CIFC. These are the, so it has 2 types also. Network file system, and it also uses common internet file system. I hope you write your own better than mine, because I'm using mouse while you are using a pen. NAS, it has NFS, that's network file system, and it also have CIFS, that's common internet file system. These are the protocols. So let's go back and see how far we can go. Yeah, we complete this. Yep. So storage types of storage forms. Basically, there are 2 types of storage in networks. Okay, 2 main types of storage in networks. That's what is called centralized storage and distributed storage. Okay, centralized storage. Just what you need to know. I will tell you the main point that you need to know. The centralized storage, all the storage devices, the disk, okay, are connected within the same physical location. Okay, but if we talk about the second one, distributed storage, the disk or the storage facilities are not connected in the same place. So you can have like they are located in different locations. You remember in the first class I was asking you, if you save your information on iCloud, where is it located? Where is it stored? We don't know. We don't know where it's located. Maybe it's stored in a database or a data center or a server that is located in Israel. What if we don't know where it's located? So that's a distributed type. Okay. So basically, the centralized type is very friendly because now we know that. Now we know what a SAN is, we know what a NAS is. And we know that a SAN uses two types of connections protocol, FC SAN and IP SAN. That is what is used also in a centralized system. Or it can simply use a NAS storage. The good thing is both connections can coexist on the same device or on the same connection, internet connection or network connection, without conflicting with each other. Okay? So you can have a NAS connection and you can have FC SAN connection, IP SAN connection, all on the same network, no problem. It's not like what I would say, it's not mutually exclusive. Okay? It can actually coexist with each other, no problem. Okay, so on the same connection, you can have both. But now, if you see this type of switch, who can tell me which type of connection is this? Sorry? Yeah, IP what? IP SAN, right? This one. Sorry, this one. Because we are using Ethernet switch, represented in blue switch, right? So that means that an IP link is used, okay? So it stores the information in this through the controller, ISCSI storage controller, and you have bunch of disks located in the same place. Okay, that's why it's centralized. All the disks are located in the same place, in a central place, basically. All the disks are located in a central place. Let's look at the distributed type. The distributed type looks like this. This is the second one. Okay. You can have many servers. Server 1, server 2, server 3. Okay. These servers and devices connected through them want to save information. It saves the information in resource pools. Resource pools are a bunch of disks, okay, located in different hosts, okay, in different basically locations. Okay, so this probably is in Lusail, another one is in maybe in Saudi Arabia. Okay, but then the server have the ability to store the salam. The server have the ability to store this information in this one, and it can also store on this one. And if you have issue with these connections, okay, replicate of the information can be found in another one. That's why the cloud service is very difficult to be to be disconnected completely. You can always find a way to retrieve your information in a distributed cloud environment. So you have all these connections, all these disks, but they are actually located in a physically different locations. Geographically, the physical information is stored in a different place. Okay, so I added also this information to it, stored across multiple physical locations. That's to tell you that it's not located in the same place. I think this is the keyword that we need to remember when we discuss distributed systems. So the last slide for today is to discuss objects. Objects also is very easy to understand now that we know about SAN, we know about NAS, right? Now let me tell you something. When we discuss the advantages of a NAS, we said it's for what? File sharing, right? File sharing, NAS is for file sharing. When we discuss about the advantages of a SAN, we said it have high availability, high speed, and it can give like direct access. Okay, so basically, this first section is about SAN. This second section is about NAS. Now we are trying to create another technology. This technology wants to combine the advantage of a SAN and the advantage of a NAS together. File sharing, high speed. Okay? So you can see I try to write additional information. Object storage, try to combine the advantage of a SAN. Look at it here. SAN, which is high speed and direct access. Also, they want to add additional advantage from NAS, which is what? File sharing. So that's the idea of this side. Okay? Object storage. To do this, they create what is called objects. Objects are actually a bunch of stuff like video files, audio files, documents, bunch of stuff are called objects. So they classify them as objects and then they will use it to do the transition, okay, or transfer from the server to the hard disk. So instead of dealing with, basically dealing with files directly, now we are dealing with the files as objects, okay? So objects can either be a video, audio, file, or images. This is additional information also I added. Okay, so basically you can have these objects, bunch of videos and files, another object, bunch of videos and files, another object, bunch of video and files. This can be transferred into what is called keys, data, metadata, and user-defined data. So objects are now treated as a single unit, which is called object system. Objects are now transmitted to the server, okay, from the server to the disk and backward, okay. Now, we already know about the SAN. SAN uses all these protocols. NAS uses these protocols, but we don't know the protocol that is used for objects. For object storage, it uses normal protocols like HTTP, REST, and S3 protocols. These are the protocols that are used in objects, basically, so that at the end of the day, we can have the ability to be able to share files, okay, have the high speed and direct access as we required. However, it still comes with some limited issues. File structure, flat structure and nearly unlimited capacity expansion is one of the advantage. Okay, more intelligent and self-management is another advantage. Standard internet protocol of the industry like the HTTP that we mentioned, this is standard protocol. It can be used here, basically. So this is another advantage. Application scenarios, it can be used in internet-oriented storage, archiving, and also in backups. So this is another advantage. So basically, they try just to get more advantages in creating files by using what is called an object. An object is a bunch of videos and audios and stuff like this. Any question? Now, the information is too much. We will stop here. Even if you didn't mention, I know that the information already is too much. The slides are not much, but maybe the way I explained, it takes more time to add more flesh to the discussion. Okay. So inshallah, in the next class, we will discuss about RED technology, okay, or RED devices. I believe if you have taken forensic before, you have an idea of a RED device, okay, so it will be easy for us to understand this. Though there may be little bit of additional information here, but it's okay, we can manage. So we can have RED 0, RED 1, RED 2, RED 3, RED 4, RED 5, RED 6, as we know it in forensic also, okay? And then addition of 0 and 1, like here, 0 and 1 will give you 10, okay? Yeah, like this. So we will come and discuss this in the next class. That will complete the chapter, inshallah. So any question? My first question, what is storage? Storage, what is storage?
There is no something specific.
Yeah. But how do you define it in your own way?
Store the information, data, files.
A place where you store information, data files. Yeah, that's good. Retrieve, storage, and stuff like this. Okay. My next question is, what will you say is like the main difference between a SAN and a NAS? SAN and NAS.
That's for the file shared file.
File storage, file sharing. Okay. How about SAN?
So now the storage, the physical storage.
Physical storage of what? Yes, yes. Block level. You remember something like block level storage? Yeah, it does storage in block level. Uh, no, discard.